So, good evening, everyone. Hello, Harish. Hello, Leon. Hello, Sharma, Gopal, introvert. Everyone, good evening, all. So, guys, yeah. So today our agenda is what we will discuss about the while loop, do while loop, and after that we will see a amazing problem statement. Okay, we will try to optimize that code, and yeah, we will see what is the importance of time complexity here. Okay, so yeah. Good evening all. Good evening, Dheeraj, Rami, Bharnath. Okay. So, guys, till this point, it is clear, right? What is variable, how to declare a variable, what happened behind the scene, right, everyone? Sir, palindrome topic. Okay, yeah. We will try to see this problem statement, what like how to check whether the number is a palindrome number or not. Okay. So, guys, without wasting our time, let's start our session. Okay. Let me share my screen. So, yeah. So my screen is shared here. So guys, we are discussing about the control statement in the previous session, and we saw like in Java what happened. We have the program, and the program gets executed in a sequential order, right? And we saw with the help of, okay, 1 minute here. Okay, we will discuss about the topic. Okay, guys, please be patient here. So we had the control statement, and we saw key if we want to skip a part of the program, then we can use selection statement. And if we want to execute the same part of the program, same logic again and again, then we can go with iterative statement, right? And we discuss about the for loop. In the for loop, we have what? We have the initialization part. After that, we have the conditional part, and after that, we have the updation part, right? So only for the first time, initialization part gets executed. After that, condition is checked. If the condition is true here, then we will execute the body of the for loop, and after executing the body of the for loop, we will go to the updation part. Our updation parts get executed. Again, we will move to the condition part, and this process continue till the point our condition expression is false. The moment the condition expression is false, then that means we will move out of the for loop, right? So here the main point is what? When we have to use for loop. Okay, you can use your for loop when you know the number of iteration beforehand. You know the starting point, you know the end point, and you know how many times you want to iterate your body of the for loop, right, everyone? Then we can go with for loop, and we can use while loop also there. But like when the main use case of while loop is what? When we have the code and we want to execute that code and we don't know about the number of iterations, right? Then we can go with while loop here. So here, let's discuss about the syntax of while loop here. Okay, so you can see we have the while keyword. After that, round bracket. Inside the round bracket, we have to write the condition. Okay, curly bracket, open and close, and inside the curly bracket, we write the body of the while loop, and we write the updation part. Okay, after one iterations, how many steps I have to climb, that we have discussed in the yesterday session, right? So here you can see the diagram here. 1 minute, yeah, this one. So here what happened first? Here also first initialization parts get executed only for the one time. Only for the one time your initialization parts get executed, and after that we have the condition check. If the condition is true, we will execute the body of the while loop, and inside the body of the while loop, we'll write the updation part also. Okay. After executing the body of the while loop, we will again go to the condition part. Okay. We will again go to the condition part, and our condition part is checked again, right? And this cycle will continue till the point the condition is false. The moment the condition is false, you are saying ki hey, I am moving out of the while loop. Okay, so this is a basic flow of while loop here. Let's try to discuss this while loop. Okay, so let's try to see, like I'm saying ki hey, you have to use for loop when you know the number of iterations, right? When you know the number of iterations ki hey, I have to climb 20 stairs, and I know the ground level, that is 0, and I know the end point, that is 20, right? So here we know the starting point, we know the end point, we know the range. Okay, that's why we are using for loop here. Okay, let's see when I can use while loop. Okay, here I'm saying ki, hey, we can use while loop when I don't know the number of iteration. I know a point where I have to stop. Okay, I know a point where I have to stop. Then in that case, I can go with while loop here. Okay, so let's discuss a program here. The problem statement here is 1 minute. Yeah. Okay. So the problem statement here is I have to write a program to check whether a number is palindrome or not. Okay, I have to write a program in order to check whether the number is a palindromic number or not. Okay, can you guys write in the comment what is a palindromic number? Anyone? Please write in the comment. Okay, please write in the comment what is palindromic number. And Leon, here Leon has one doubt. He's saying yes, but if a user types a number greater than 0, then it will never be less than 0. So it is infinite loop. Yeah, how we solve this? Okay, so if you have it like you are saying hey, my number is increasing, okay, and the condition is true always, then you will go to the infinite loop. Okay, 153. Divi, why you are saying 153 here? Praveen is correct here. 151. Leon is also correct here. 454. 454. And no, 149 is not a palindromic number. Okay. So what is a palindromic number here, guys? I have a number, and if I will reverse that number, the original number and the reverse number both are same. If I am reading from left to right, or if I am reading from right to left, okay, and if I am getting the same result, then I am saying ki, hey, the number is a palindrome. The string is a palindrome, right, everyone? Hi, do you speak? No, no, no. Hi. Okay, this is an English session here, so we will discuss this session in English. Okay. Correct, everyone. So everyone is clear here. They are saying, hey, if I am reading from left to right, or if I am reading from right to left, then I have to say, then that number is a palindromic number. Okay, let's take one example here. Okay, I have a number here that is 1331. Okay, this is my number here. So now I know I have a brain here. We have a brain. We human have a brain. So we can see the number and like we know the definition of palindromic number. So we can easily identify whether the number is a palindrome or not. So how to tell the computer? Okay, computer is an intelligent machine, but here computer is dumb. You have to tell each and everything to the computer here. Okay. So here, let's try to observe. This is my number here. Okay. This one, right? So if somehow I can reverse this number, okay, if somehow I can reverse this number and store the result of the reversed number in some other container, okay, and the original container and the reversed container, if both the data inside the reverse container and the original container are same, then we can say the number is a palindromic number here. Okay, everyone. So here you are saying, hey, this is your original number, okay, that is original number is, okay, original number is 1331. Okay, and you are saying ki, hey, let's take one more variable temporary in order to preserve my original number. Okay, I have preserved the original number. Let's assume this number is preserved inside the container num. Okay, here, so I have preserved the original number here, and I'm saying ki, hey, what I can do here, let's try to preserve this number. Temp is equal to num. Okay, so what I got the same data inside the temp container, right? I got the same data inside the temp container here, and now I'm saying ki, hey, let's do the task on, let's do the operation on this temporary variable here. Okay, so I have this number, and what I have to do, I have to reverse this number. Okay, so what will be my first step? Okay, I have to somehow take the last digit from the number and store the digit in another variable. Okay, I am saying ki, hey, let's somehow separate the last digit. Okay, 133 and 1. Okay, and I'm saying ki, hey, let's try to store this in another variable, that is digit here. Okay, digit here. So this is digit here. Okay. Yeah. So now my original my temporary number is what? 133, and inside the digit what I have? I have 1 here. Again I am saying ki, hey, please extract the last digit from the number, that is 3. Okay, please extract the last digit from the number, that is 3 here, and store this number inside digit, right? So here you are saying ki, hey, this, and you are saying 1 3, and you have extracted 3, and you are saying ki I will put 3 behind 1 here. Okay, behind 1 here. After that, again you have to again you have to execute the same logic, that is, you have 13, you are saying ki, hey, I am extracting the last digit, that is 3, and the number remaining is what? 1 here inside the temp variable, and inside digit you are saying I have added the extracted number behind the digit, right? That is 133. Okay. After that, again you are saying, hey, what I will do? I have 1 here. I will extract 1. I will extract 1. And after extracting 1, here inside temp, I have 0. And here I am saying inside digit, what I have to do? I have to add the last extracted digit behind my digit number, right everyone? So here you can see what I am doing at each iteration. At each iteration, first I am extracting, okay, you are extracting the last digit, from temp, okay, and after extracting the last digit from the temp, what you are saying? You are saying, hey, insert the last digit, last extracted digit, here, last extract digit in my digit variable, okay, in my digit variable at rear end, okay, at rear end, right everyone? So this pseudo code you have to follow, and you are saying ki, hey, this I am doing again and again till the point you are getting your temp as 0, right everyone? You are getting your temp as 0. Okay, so let's try to write the code now. Here we are saying ki, hey, our Java Bootcamp Essentials, inside this we have the source file, and here right click, new class, name of the class is Palindrome. Okay, and here public static void main, Palindrome here. And what we are doing wrong here? 1 minute. Yeah, new class, and here Palindrome, public static void main, and finish here. Okay, so your class is created here, and here you have to write the code. Okay, so first thing you are saying ki, hey, let's take a digit. Okay, int digit, and I know how to take input from the user. Okay, I have to use a class, that is scanner. I have to create the object of scanner class. Sc is equal to new scanner system.in, right? We have discussed about this syntax, right? This is my object of scanner class, system dot in here. Okay, and after that I have to include the package, that is java.util here, right? In order to use the object of scanner class, I have to include the package here. After that you are saying ki, hey, int original number is equal to what? Int original number is equal to sc dot next int. Okay, we are taking input from the user here. And after that you are saying what? I got the original number. Okay, I got the original number here. What I have to do? I have to first preserve the original number. So I am taking one more variable, that is temp here, and I am saying ki, hey, original. Okay, please assign the data of original inside the temp variable, right everyone? Okay, after that what I have to do? I am saying ki, hey, till the point temp is not equal to 0. Okay, till the point temp is not equal to 0, or you can write till the point temp is greater than 0. That means there are some digits still left. Okay, there are some digits still left inside the temp variable. Okay, here. After that, let's take this digit as reverse. Okay, reverse here is equal to 0. Okay, after that you are saying what? You are saying, hey, let's first extract the number here. Okay, this one. So in order to extract a number, can you guys write in the comment what basic math we have to use here? How to extract the last digit from the number? Everyone, please write in the chat. How to extract the last digit from the number? Okay, anyone? Modulo, correct. Everyone is here. Praveen is correct here. Modulo, yes, everyone. So here what we have to do? We are saying ki, hey, I have a number that is 1331, and if I'm taking the modulo of the number with 10, okay, then what I will get? Then what I will get, guys? I will get the remainder part, okay, and the remainder part here is what? 1, right, everyone? And if I am dividing my original number with 10, then what I will get? I will get the quotient part, that is 133, right, everyone? With the help of the modulo operator, we are getting the remainder part, that is we are extracting the last digit, and with the help of division, what we are getting? We are getting the quotient part, that is my remaining digit left, right? That is my remaining digit left here. So you are saying, hey, now I know how to extract a number from the digit, the last digit, and I know how to retain the remaining digit, right? With the help of modulo and division operator. So this concept I have to use here. So what I will do? I am saying, hey, int digit. Int digit, the extracted digit is what? Your temp modulo 10, right? With the help of this line, you will get the extracted digit stored inside your digit variable, right, everyone? After that, you are saying, hey, after extracting the last digit, I want the remaining digit. So in order to get the remaining digit, you are saying temp divided by 10. So you will get the remaining digit. And you are saying, hey, the remaining digit where I will store? I will store inside temp again. I will store inside temp again. Okay. And you are saying, hey, now what I have to do? I have extracted the digit. I have stored the remaining digit inside the temp variable. Now I have to add the extracted digit behind the reverse variable, behind the reverse number. So here you are saying, hey, reverse is equal to what? Everyone please write in the chat how to add the last digit at the rear end of a number. How to add the last digit at the rear end of a number. Okay. So you are saying what? Here, 1 minute. Yeah. So you are saying, hey, I have 1, 2, 3, and I have to add 1. I have to concatenate 1, 2, 3 with 1. That is my final result should be 1, 2, 3, 1. Okay. I want this result here. So it is clear. So here, tech tutorial is saying multiply by with 10, and yeah, he's correct here. He's saying, hey, 1, 2, 3. If I will multiply with 10, what I will get? I will get 1, 2, 3, 0. And in this result, I will add the extracted digit. So what I will get? I will get the overall concatenated result. Right, everyone? That is 1, 2, 3, 1. Right, everyone? So this step I have to follow here. So reverse is equal to reverse into 10 plus digit. Right, everyone? And this process I have to repeat till the point my temp is greater than 0. The moment temp is greater than 0, that means I have taken all the number from the temp and I have reversed the digit. I have added the digit at the rear end of the reverse number. Right, everyone? So this is a code here. So here you can see I know a point where I have to stop, but I don't know the I don't know the specific range. Okay, I don't know the specific range. Okay, so I'm using a while loop here. Okay, and inside the while loop, I am writing the logic. I am executing the logic again and again. So here I have to use while loop here. Okay, everyone. Can you guys tell me? Yeah, it is clear, right? Okay. So what I have to do here? Now I have to write a check ki if my reverse number is equal to original number. Okay, is equal to original number. Then I have to print what? I have to print that the number is a palindromic number, right? System dot out dot print ln, and here you are writing palindrome, right? Palindromic number here. In the else part, you are saying ki, hey, if the first condition is not true, I will move to the else part. And here what I will write? I will write the number is not a palindromic number here, right everyone? Not a palindromic number here. So the logic and the intuition is clear, guys. Please write in the chat. Okay. So let's try to run this code here. Okay. In order to run the code, I have to go to the run button and I have to hit on the run, right? And you can see it is asking for the number. This means that is first line number 5 gets executed. After that, you are at line number 7, that is inside reverse, you are getting 0, and after that you are taking input from the user, right? Let's take the input as 1 2 1. Okay, 1 2 1. Okay, let's see whether I have written the correct code or not. Okay, so the number is a palindromic number here, right? Let's try to run the code, and this time I have to type the number that is not a palindrome number, right? 1 2 3 4 5. Okay, so here you can see the number is not a palindromic number, right everyone? The concept is clear. You have to break your problem statement into a smaller part. Okay, first, like my first approach is what? I have to check whether the number is a palindromic number. So I got the definition of a palindromic number. That is, if I am reading from left to right or I am reading from right to left. Okay, if the number is same, that number is a palindromic number. So I got the idea ki yes, if somehow I'm able to reverse the number that is my original number and compare the reverse number with the original number, and if the data is same here, then I can say the number is a palindromic number. Okay, then the main question arises ki how to reverse the number. Okay, the main question arises here, how to reverse the number. So you are saying ki hey, in order to reverse the number, I have to extract the last digit and I have to concatenate the last digit in the digit variable here. Okay, in the reversed variable here. Okay, and yeah, this process I have to follow till the time your temp is 0, till the time there are no number left inside your temp variable. Okay, so you got the reverse number, you got the original number, and you are comparing both the number, and with the help of that you are getting the result. And you are saying ki hey, I have to execute the same logic again and again till the point temp is not greater than 0. Okay, so I know ki I have to stop, I have to use loop. Okay, so here I don't know the particular range, I don't know the starting point and the end point. Okay, so I am using here while loop. Okay everyone, it is clear. So let's see. Question not given assignment today. Okay, you will get the question, guys. My code has a problem. Please write the code in the comment here. And here, like someone is saying something, right? ARR of 0 1 we can write with the help of array also. Okay, tech, if you are saying ki hey, what I will do, I will take the number and I will store the number inside the array and I will use a for loop. Okay, in order to check whether the number is a palindrome number, then you are using an extra space, right? You are using an extra space here, right? So apart from that, do you guys have any doubt? Please write in the chat, right? Okay, so okay, yeah, so you have to write your code in such a way that you are using minimum space and you are using less time. Okay, okay, Leon, what did you not got in this part, right? Please write in the chat from where we can get assignment question. Okay, you will get the assignment question, they will send you in the link, right? So apart from that, in the concept part, anyone has any doubt, please ask. Okay, what is solving one problem statement? It is there in assignment. Solving one problem statement. Okay, so yeah, so I'm hoping you got the while loop here. Let's discuss about the do while part. Okay, okay, here you are saying The last loop is what? Do while loop. Okay, the difference between while and do while loop is what? Here, the syntax part is different here. Okay, here also you have to use do while loop when you have to execute the group of logic again and again. Here the difference is what? The logic that you are writing inside the while loop will get executed one time irrespective of the condition. Okay, irrespective of the condition, your logic will execute for the one time. Okay, so here you have the do keyword, after that you have the open and the close curly bracket, and after that you have the while keyword, round bracket, and here you are writing the condition part. So in the diagram you will get the clear idea key. Yes, what is happening here? We are in the do part. Okay, first, for the first time we are doing what? We are executing the body of the do while loop. Okay, we are executing the body of the do while loop. After that I am checking the condition. But in the while loop, what we are doing? We are first checking the condition, after that we are moving inside the body of the while loop if the condition is true. And here we are for the first time we are executing the do while part, the body of the do while part. After that we are checking the condition. If the condition is true, we are going again to the body of the do while part. Again we are checking the condition, and this process will continue till the point your condition is false here. So the difference between while and do while is what? First the syntax part, and the second is what? For the first time your body of the do while will execute irrespective of the condition here. Right, everyone? Yeah. Okay. So basically, Priyanka, we have discussed about the next int part in the next session. Please watch that tutorial there. Okay, what we are doing with the help of next int? Next int is a function that is defined inside the scanner class, and with the help of the object of the scanner class, what we are doing? We are converting the dump data to a integer part. Okay, please watch the previous session and you will get the clear idea. Okay, so here my code goes infinite loop while. Please try to dry run your code, Leon, and you will get the clear idea, right? So let's take a problem statement here, and let's see how I can optimize the problem statement, and yeah, what is the importance of time complexity here. Okay, guys. Okay. So here the problem statement is what? 1 minute. Yeah. Here. The problem statement here is what, guys? Write a program to check whether the number is a prime number or not. Please write in the chat what is the problem statement here. Okay, please write in the chat what is the prime number here, guys. Okay, you can go to the Let's Upgrade, and from there Let's Upgrade this YouTube channel, and from there you can watch the session. Okay, the previous session. Guys, here the question is, what is the prime number? Everyone, please write in the chat. Prime number here. Okay. Let's see who know prime number. Anyone? Yeah. Okay. I'm still waiting for your answer, guys. Please. Okay. So, guys, here prime. Okay. Can you write the definition, honey? What is the prime number here? Please write the definition. Okay. Tejas is saying here number which is divisible by 1 and the number itself. Okay. This is math. We are not mathematics here. Okay. But you have to use a simple math here, Leon. Okay. If you are solving any problem statement, you have to use a basic math. Okay. You don't have to be expert in math, but you have to use a basic math here. Okay. 1 and itself divisible by number divisible by 2. Programming, we are saying what is a prime number, not a even number. Okay. Not divisible by any number. Okay. Wrong definition here, and yeah. So like most of you are saying what a prime number is a number. Okay. According to the audience here, they are saying prime number is a number that is divisible by 1 and itself, right? 1 and itself, right? Yeah, itself here. So can you guys tell me 1 is a prime number or not? 1 is a prime number or not? Please write in the chat. Okay, let's see. 1 is not a prime number, guys. Okay, so guys, you are saying the number is divisible by 1 and itself, and yeah. So my question here is, if your definition is clear, correct, then 1 is not a prime number, right, everyone? 1 is not a prime number here. So this definition is partially correct. This definition is partially correct here. Okay, so basically, prime number are number that is having exactly two unique factor. Okay, that is having exactly two unique factor. Exactly two unique factor. Okay, and these factors are one and itself. Okay, these factors are one and itself. You guys are getting the point? Exactly two unique factor, and these factors are one and itself, right, everyone? Yeah. So you are saying, hey, now I know the definition of prime number. That is, I have to check how many factors a number have. If the number of factors of a particular number is equal to 2, that means that number is a prime number. Okay, and if the number of factors are not equal to 2, then that number is not a prime number here. Okay, let's take example here. You are saying, hey, 2 is a prime number, 5 is a prime number, right? 11 is a prime number, 3 is a prime number, right? 7 is a prime number. Similarly, 13 is a prime number. So all these numbers have exactly two unique factor, that is 1 and itself. That's why 1 is not a prime number, because 1 has only one unique factor, not 2. Okay, and this is the definition here of a prime number here. So you are saying, hey, now I know the definition part. What is the prime number? So now how to tell the computer, how to tell computer you should go and check whether the number is a prime number or not. Okay, so I know what I have to do. I have to calculate two unique factors. Okay, factors are what? Number that are divisible by that given number, right? So you are saying, hey, in order to check the number of factors, what I can do? Okay, let's see here. For 8, for 8, please write in the chat what all factors 8 contains. Please write in the chat what all factors 8 contains. Okay. Please write in the chat, guys, what all factor 8 contains. So here, Tejas is saying, he is correct here. That is 1, okay, 2, 2 is also divisible by 8, 4 and 8. So here 8 has 4 factor. That's why 8 is not a prime number, right? Similarly, if I will say, hey, please write in the chat how many factors 7 have. How many factors 7 have, guys? Please write in the chat. Okay, let's see. Leon, what you are not able to get? We are discussing about prime number, and we are saying ki the number that is having exactly two unique factors, that number are called prime number, and these factors can be one and itself, right? So on that basis, we are first checking how to calculate the number of factors. So here they are writing the chat, and it is clear here ki 7 have two unique factors, that is 1 and 7. So here two unique factor, so that means 7 is a prime number. Similarly, if I will write in the chat, let's take one more example here. Okay, please write in the chat 37 is a prime number or not, guys. Please write in the chat 37 is a prime number or not, everyone. Okay, let's see. How many factors 37 have? Okay, yeah, 37 is a prime number, but why? Okay, you have to calculate number of factors, and factors is what, guys? Factor is what? Multiples of that number, right? If I am saying ki, hey, so multiple of 8 is what? 1 is a multiple of 8, that is 1 is divide. If I will divide 1 by 8, then it is divisible. 2 is a multiple of 8. Sorry, 2 is divisible by 8. 4 is divisible by 8. 8 is divisible by 8, right, everyone? So that's why these are what? Factors, right? So they are correct here. We are saying ki, hey, The factors of 37 are what? 1 and 37, right? 1 and 37 are factors of 37. That is, 1 and 37 are properly divisible by 37, right? Apart from these two numbers, we don't have any number that is divisible by 37, right? Okay. 1 and 37 is a prime number here. Okay. Yeah. So let's see now. So you are saying कि hey, in order to calculate the number of factors, what I have to do? I have to start from 1 and I have to go to the point for which I have to find a prime number, right? For which I have to find a prime number. So here you are saying कि hey, I will use a for loop, and inside the for loop you are saying कि hey, my starting point is what? 1, okay? Because 1 can be a factor of a number and I is less than equal to that number, okay, for which I have to calculate the factor, and after that I plus plus, right? And here let's take the number that is int num is equal to, let's suppose 27, okay? Int num is equal to 27, and here you are saying ki, hey, I am going from 1 till 27, okay? And here inside the body of the for loop you are saying ki, let's see how to check whether the number is a factor or not, right? So here you are saying ki, hey, if your number modulo I is equal to 0, that means that number is a factor of num, right? That number is a factor of num here, right? So here you are saying ki, hey, if num modulo I is equal to 0, that means I is divisible by num, and yes, I is a factor of num. So what I will do, I will take one more variable to store the count part, that is int count is equal to 0 here, and the moment I will get a number that is divisible by num, what I will do, I will increase my count here. I will increase my count here, that is count is equal to count plus 1, right everyone? And this process will continue till the point I am from 1 till the number, okay? The moment I will move out of the number, then you are saying ki, hey, I got the total number of factors, right? And that number of factors are stored inside your count variable, right everyone? So you are saying ki, hey, I got the number of factors. Now I know the definition of a prime number. That is, if your number of factor is equal to 2, that means that number is a prime number, right? So here you will write what? System.out.println, the number is a prime number here, okay? Okay, here prime number. Else, if the number of factors are not equal to 2, that means that number is not a prime number here. Else, not a prime number here. Okay. The intuition is clear. The approach is clear, guys. Anyone has any doubt, please write in the chat. Not a prime number. Right, everyone? Anything you have to ask till this point, please ask. Okay. So I didn't even understand what a factor is. Okay. So basically, Leon, if I am saying, hey, you have, let's suppose you have 6. Okay. You have a number 6, right? And you have to count, like if you have to check a number that is any number. Okay. And that number is divisible by 6. Okay. Okay. That number is a factor of 6. Then you are saying, hey, that number is a factor of, that number is a factor of a particular number here, right? So like what you are not able to understand in the factor part. Okay. So here I have a number 6, right? And I'm taking one more number, that is 3. So 6 divided by 3 is what? 2. So 3 is a factor of 6, right? A number that is divisible by that number is called a factor. Okay. Like how you can divide all, Leon? How you can divide all? Can you tell me? Let's take this example only. You are saying, hey, 6 divisible by 1 is possible here. That is, we will get the result as 6 here, right? And if I will say 6 divisible by 2, right, is equal to 3 here, right? And you are saying 6 divisible by 3, okay? You are saying 2, you will get. So these all are what? Factors, because these numbers, that is 1, 2 and 3 are divisible by 6. Let's take 6 divisible by 4, okay? So here 6 is not divisible by 4. 6 is not divisible by 4. So you are saying ki 4 is not a factor here. Okay, not a factor here. Similarly, if I will say 6 divisible by 5, 6 divided by 5, you are saying ki hey, 6 is not divisible by 5. So 5 is also a 5 is also not a factor here. Okay, not a factor here. Again, you are saying 6 divisible by 6. So this time 6 is divisible by 6. So you are saying ki 6 is a factor of 6. Now, Leon, you got? Yeah, clean divide. Yeah, clean divide. Okay. Yeah. So let's move to the part. So what we are doing, we are saying ki, hey, we know the definition of a prime number, that is having exactly two unique factor, and you saw ki those factor lies between 1 and the number. So you are using a for loop. You are saying ki, hey, I know the start point, that is 1, and I know the end point, that is num. Okay, and what I have to do, I have to iterate, and I have to check a condition here. If that number is clean divisible, okay, if the number is divisible by I, then I is a factor of num here. What I am doing, I am increasing the count. I am saying ki, hey, I got the one factor. That's why I am incrementing my count here. And after that, I am writing a check here. Till this point, everyone is clear? Okay. Take 32, sir. Okay. 32, like what you want in 32? Should I calculate the factor of 32 as input? Okay. Let's see. So if you will take 32 as input here, simple, right? This one, 32. So here, 1 is a factor of 32, 2 is a factor of 32, right? So here, after that, the next factor is what, guys? 4, right? 4 is a factor of 32, right? So here we are having more than 2 factors. So this is not a prime number, right? Okay. Abhay, we will come to this point, okay? Till this point, everyone is clear? Okay. How to calculate the number of factor and how to check whether the number is a prime number or not, right? Okay. Yeah. So let's try to make some interesting analysis here, okay? Yeah. So you are saying, hey, now I know how to calculate a factor, and someone is saying, like most of you are saying, hey, you can go with num divided by 2. Okay, this will also work. Okay, we will come to this part. Okay, if those who don't know about this fact, that is num divisible by 2, why we are writing num divisible by 2, okay, how you should think about this, like how you should go in this direction, key you have to reduce the number of iterations. Let's see why we have to reduce the number of iterations here, right? So here you are saying, hey, now I have a system. I have a system here, okay? I have a system here, and we are saying, hey, in my system, in my processor, what I have, like my processor is doing what? It is doing 10 to the power 9 iteration, 10 to the power 8 iteration, okay? 10 to the power 8 iteration in 1 second, okay? 10 to the power 8 iteration in 1 second here. I have a system, and the processor here, it is saying, hey, I will do 10 to the power 8 iteration in 1 second. Iteration is what? Number of time the body of the file for loop will get executed. Number of time the body of the for loop will get executed. That is called iteration. Right, everyone? So here you are saying, hey, I have a system, and in this system, my processor is doing what? 10 to the power 8 iteration in 1 second. So you are saying, hey, can you guys write in the chat how many iterations this for loop is doing? Please write in the chat how many iterations this for loop is doing. Everyone. Okay. That is how many times your body of the for loop is getting executed. Okay. You got the idea? Yeah. Here our problem statement is what? We have to calculate number of iterations. Yeah, Leon is correct here. He's saying less than equal to num. Okay. Yeah, if you are taking the value of num is equal to 27, then 27 times my body of the for loop will get executed. That means 27 number of iterations. Okay. And if I am calculating the number of iterations in term of num, then you are saying the number of iterations is equal to num here. Okay. So you are saying, hey, I have a system here, and in this system I have a processor that is doing execution of 10 to the power 8 iteration in 1 second. And let's assume you have to check whether n is equal to 10 to the power 9 is a prime number or not. Okay, is a prime number or not. So guys, can you tell me this code will run for how many time? This for loop will run for how many time? If the value of n is 10 to the power 9. If I have to check whether 10 to the power 9 is a prime number or not, please write in the chat. Okay. The question is clear, right, everyone? We have n is equal to 10 to the power 9 and I have to check whether 10 to the power 9 is a prime number or not. Then how many time my for loop, the body of the for loop will get executed? That is number of iterations. So here tech is correct here. He is saying ki, hey, since it is starting from 1 and it is going till num, and if the value of num is 10 to the power 9, then the body of the for loop will execute for 10 to the power 9. Right, everyone? So here you are saying ki, hey, I have to check whether 10 to the power 9 is a prime number or not, and for this I have written a code. I have written a code in which my for loop is doing 10 to the power 9 iterations, right? 10 to the power 9 iterations. So guys, can you write in the chat, if this is the configuration of my processor, then how much time my processor will take to execute, to check whether the number is a prime number or not? Okay, please write in the chat. So here you are saying ki, hey, 1 iterations, okay, 1 iteration is equal to 1 divided by 10 to the power 8 second. Okay, I can write this line, right? Yeah, this one. 10 to the power 8 iteration in 1 second. So 1 iteration in 1 divided by 10 to the power 8 second. Okay, and in order to check whether 10 to the power 9 is a prime number or not, and my code is doing 10 to the power 9 iterations. So here you are saying ki, hey, 10 to the power 9 iterations will take how many second here? That is equal to 10 to the power 9 divided by 10 to the power 8. Right, everyone? And you will get how many second here, guys? 10 second. Okay, 10 second. So you are saying ki, hey, okay, I have written a code and my computer is taking 10 seconds to check whether 10 to the power 9 is a prime number or not. Okay, and you are saying ki, hey, 10 seconds is too less, so I can wait for 10 seconds. Okay, I can wait for 10 seconds, okay, to get the result. Let's take the value of n is equal to 10 to the power 18 this time. Okay, now the value of n is 10 to the power 18. And you are again saying ki, hey, I have to check whether 10 to the power 18 is a prime number or not. So you are saying ki, hey, since I am using a for loop and that for loop will do number of iterations is equal to n, that means my for loop will do 10 to the power 18 iteration here. Okay, my for loop will do here 10 to the power 18 iteration here. So guys, again, let's try to run the same code on my same processor that is having this configuration, that is 10 to the power 8 iteration in 1 second. Okay, so you are saying 10 to the power 8 iteration in 1 second, then 1 iteration is equal to 10 to the power 8 second. 1 divided by 10 to the power 8 second. So 10 to the power 18 iteration is equal to 10 to the power 18 divided by 10 to the power 8 second. That is equal to 10 to the power 10 second, right? 10 to the power 10 second. Can you guys write in the chat? Can you guys write in the chat how much time this is? Okay, how much minute, how much hour I have to wait to see whether 10 to the power 18 is a prime number or not? Okay. Again, guys, those who are not able to get the point, what we are doing, we are saying I know number of iterations, my for loop is doing n number of iterations, and this is the configuration of my processor. That is, my processor is doing 10 to the power 8 iteration execution in 1 second. Okay, 10 to the power 8 iteration execution in 1 second. Then you are saying ki, hey, in one iteration, how many time my computer will take? It will take 1 divided by 10 to the power 8 second, and this value is hypothetical value. Okay, this value is hypothetical value here. So you are saying ki, hey, if I have to check whether 10 to the power 9 is a prime number or not, then This is a simple math and I am getting 10 seconds. Similarly, I am saying ki, hey, you have to check for 10 to the power 18 whether 10 to the power 18 is a prime number or not. For this, you are saying ki, hey, again my program will take 10 to the power 8 iteration and again the same configuration, and we are getting 10 to the power 10 second. Okay, everyone? Okay. So please write in the chat 10 to the power 10 second is how much time? Okay, it is 1 day, 1 year, 1 month. Any guess? Anyone? So anyone, please write in the chat. So this is equal to 317 year. So you are saying ki, hey, I have a computer that is taking 317 year to check whether the number is a prime number or not. If I have written this logic here, if I have written this logic here, and you are saying ki, hey, in order to check a prime number or not, you are using a for loop that is starting from I is equal to 1 till I less than equal to num. So most of you are saying ki, hey, why you are using less than equal to num? If you will do num divided by 2, then also your code will work. Then also you will be able to calculate all the prime factor, right? You will be able to calculate all the prime factor. But if I am here doing a small optimization, this num divided by 2 here, and I am having 317 here. Okay, 317 year divided by 2, again you will get somewhere approx 200 here to check whether a number is a prime number or not. Okay, you are going in the right direction, but what you are doing, you are not able to minimize your time complexity here, right everyone? Okay. Yeah, Icon, we will come to this part. Can we use break when all iterations are necessary? Okay. So those who are not able to get this part, okay, till this part it is clear. The main problem is what? Time here. That is, my program is taking 317 here to check whether 10 to the power 18 is a prime number or not. Okay, let's try to see now how to observe my code and how to optimize my code here. Okay, so this is my code here, and yeah, okay, let's see. Yeah. So guys, you are saying ki, hey, here I can write one line ki, yeah, I have n. Okay, let's take n is equal to 24. So you are saying ki, hey, if I know one factor of 24, if I know one factor of 24, then I can easily get the next factor. Okay, if you are saying ki, hey, 2 is a factor of 24. 2 is a factor of 24. Then you can say ki, hey, 12 is also a factor of 24, right? 12 is also a factor of 24. How? 24 divided by 2, you will get 12. Okay. And if you will take the dividend part to the right hand side, then what you will get? You will again get 12 into 2 is equal to 24. So you are saying ki, hey, if I know one factor, I can easily get the next factor also, right? Similarly, you are saying ki, hey, 24, okay, here we are having 3. 3 is a factor of 24. So the next factor is what? 24 divided by 3, you are saying 8. So 8 is also a factor of 24. Right, everyone? 8 is also a factor of 24. Similarly, you are saying, hey, I know till this part, then 24, here you are saying 4. Let's take 4 also. 4 is a factor of 24. So you are saying, hey, 24 divided by 4, what you will get? 6. So 6 is also a factor of 24. On this observation, you are saying, hey, if I know one factor, I can easily calculate the next factor also, right? So here you are saying, hey, let's suppose n is equal to a into b. A into b. Okay, you are saying, hey, n is equal to a into b. This formula I can use. Okay, if I know 24 here, the value of n is 24 here. So if I know 2 is a factor of 24, then I can easily calculate the next factor. That is 12. Right, everyone? That is 12 here. So you are saying, hey, here you are saying, hey, if a is a factor of n, if a is a factor of n here, then I know the value of b. How I will calculate the value of b here? I will say n divided by a. Then I will get the value of b. I know one factor, I can easily calculate the next factor on the basis of this equation here. Okay, till this point, anyone has any doubt? Please write in the chat. Okay, so basically here you are saying ki, hey, my time complexity is increasing because of the iteration. Okay, if somehow I am able to reduce the number of iteration, I can optimize my code. I can reduce the time complexity to check whether the number is a prime number or not. Okay, on that basis you are saying ki, hey, since here I have to reduce number of iterations, so you are saying ki in order to reduce number of iterations, what you are doing, you are saying ki, hey, inside the body of the for loop, the main task is what? To calculate number of factors. Okay, to calculate number of factors. So you are saying ki, hey, let's focus on the number of factor part. In the number of factor part, you observe one pattern. That is, if you know one factor of a number, you can easily calculate your next factor also. If you know a is a factor of n, then you can easily know ki yes, b is also a factor, and the value of b is what? N divided by a. Right, everyone? Till this point, it is clear? Yes or no? Please write in the chat. Okay. So here, if you are saying ki, hey, let's take 36 again. Okay, and you are saying ki a, the value of a is what? Let's say 3. Okay, I know 3 is a factor of 36, right? So the next factor is what? The value of b is what, guys? Here it is 36 divided by 3, that is 12. Right, everyone? So if you know the one factor of n, you can easily calculate the next factor also, right? So first thing is what you are saying, my time complexity is increasing because of the number of iterations, and the number of iterations we are using because of the for loop. Inside the for loop, what we are doing, we are calculating the number of factor. So I have to write the code in such a way that I can calculate all the factor by reducing the number of iterations. So you observe one pattern here, that is n is equal to a into b. That is, I know one factor, I can easily calculate the next factor. Right, everyone? Okay, so let's try to see the pattern here. Okay, let's try to observe the pattern here. You are saying ki, hey, let's take the value of n is equal to 24. Okay, 24 here, n is equal to 24, and you are saying ki, hey, I have I here. Okay, bold. Okay, yeah, I have I and I have n divided by I. That is, I have one factor. If I know one factor, I can easily calculate the next factor also, right? So here you are saying ki let's start with 1. Okay, here my for loop is starting from 1 and it is going till n. It is going till num in order to calculate all the factors. So let's start from 1. So 1 is what? 1 is a factor of 24. Yes, 1 is a factor of 24. So the next factor will be what? It will be equal to 24, right? 24 divided by 1 is equal to 24. Okay, so I know the value of b. Again, the value of I will be incremented, and you are saying ki, hey, 2. The value of I is what? 2. So 2 is, yes, a factor of 24. So you are saying ki, hey, the next factor will be what? 24 divided by 2, that is 12. Right, everyone? So again, you are saying 3 is a factor of 24, and the next factor will be what? 24 divided by 3, that is 8. Right, everyone? Similarly, you are saying 4 is a factor of 24. So the next factor will be what? 24 divided by 4, that is 6 here. Again, you are saying 6 is a factor of 24. So the next factor will be what? It will be equal to 24 divided by 6 is what? 4. Right, everyone? Again, you are saying, hey, 8 is a factor of 24. So the next factor will be 3. Right, everyone? You are saying 12 is a factor of 24. So the next factor will be what? 24 divided by 12, that is 2. Okay. After that, you are saying ki, hey, 24 is also a factor of 24. Okay. So you are saying ki, hey, the next factor will be 1. That is 24 divided by 24 is equal to 1. Apart from this, if you will take the value of I is equal to 5, if you will take the value of I is equal to 7, 11, 12, then you are saying ki, hey, these are not my factor. These are not my factor, this is not the value of a, this is not the factor, so I cannot calculate the next factor also. But here you are able to, if you are able to get one factor, and you are easily able to calculate the next factor here, right everyone? So guys, my next question here is, what we are doing, we are starting from 1, right everyone? We are starting from 1 and we are going till n, that is n number of iterations. So basically in the for loop we are calculating the number of factors. Can you guys observe a pattern? Okay, my main focus is number of factors. At what point I am getting repeated factor? Can you guys write in the comment at what point I am getting repeated factor? Okay, please write in the chat, everyone. Okay, let's see you are able to observe a point or not. In this table, at what point I am getting the factors that are getting repeated? Okay, okay, Abhay is correct here. He's saying when a is greater than b. Correct, Abhay. Okay, any other observation guys in the table here? Any other observation? When a is greater than b, we are getting the number of factors repeated, right? At this point. Okay, at this point. Yes or no? Okay, Kalyan is also correct here. So you are saying, hey, you can write like this ki, hey, after a, like after a is uh, after this point, that is a is greater than b, I am getting the repeated factor. Or you can write like this ki, hey, this point, right? You have a, and till a is less than equal to b, till a is less than equal to b, I will get unique factor. The moment a is greater than b, I will get repeated factor here, right? Here you are getting repeated factor. Okay, and here you are getting, till this point you are getting, okay, unique factor. So this point you have to tell the computer also. Okay, this point you have to tell the computer also ki, hey, there is no need to start from 1 and there is no need to go till 24 in order to calculate number of factors, right? In order to calculate number of factors, there is no need to do n number of iterations. Okay, if you are doing number of iterations equal to a less than equal to b, then it is good to go. You will get the number of unique factor. Okay, you will get the number of unique factor, and the value of a is what, I, and the value of b is what, n divided by I, right everyone? N divided by I. So you know, if I will take the dividend part and if I will move the dividend part to the left hand side part, then what will happen? It will get multiplied. So in the left hand side part, you are getting I into I less than equal to n. I can write this line or not, guys? Please write in the chat. It is clear? I can write. Okay, first I am saying ki, hey, till the point a is less than equal to b, I am getting unique factor. So there is no need to iterate till n. You have to stop the moment a is greater than b. And you are saying ki, hey, the value of a is I and the value of b is n divided by I. Okay, so you are saying ki, hey, I into I is less than equal to n. Okay, yes or no, guys? Till this point is clear? Yeah. What do you mean by repeated? Okay, so Leon, repeated means here you can see when the value of I is 4, I am getting 6. Okay, I am getting 6. That means here you are getting the count as 2. Here you are getting count is equal to 4, right? Here you are getting count is equal to 6. Okay, till this point you got 6 factor. Here you are getting count is equal to 8. Okay, count is equal to 8. After that, after this point, when the value of a is greater than b, you are getting 6 and 4. You are getting 6 and 4 here, and this 6 and 4 are equal to 4 and 6 that you have already calculated above. That you have already calculated above. So here if you will write count is equal to 10, again you will add, that means you are adding repeated factor. Okay, and you know the definition of prime number. Prime number is what? number that is having unique factor, that is two unique factor. So till this point only you are getting unique factor. After this point you are getting repeated factor, that is 6 4 6 4, right? 8 3 3 8, right? 12 2 2 12, right, Leon? It is clear. So we are on that basis we are making two decision. We are saying ki hey, I have to tell computer ki till the point a is less than equal to b, you have to calculate number of factor. Till this point you will get number of unique factor. The moment a is greater than b, you have to stop. Okay, and the value of a is I, the value of b is n divided by I. So on that basis you are saying I into I is less than equal to n. So you can write I is less than equal to square root of n. Okay, I is less than equal to square root of n, right everyone? So you are saying ki hey, when the value of I is less till the point I is less than equal to square root of n, I will get the number of unique factor. Okay, so first I saw the problem statement. The problem statement is what? Time. Okay, when I am calculating 10 to the power 18 is a prime number or not, then I saw a problem key. Yes, my system is taking 317 here. Okay, 317 here. So I saw key, yes, this problem arises because of the for loop that I am using in my code. This for loop here, right? This for loop here, because number of iterations is equal to the number of times your body of the for loop get executed. So you are saying ki, okay, somehow I have to reduce the number of iterations. So you are saying ki, let's see, you are saying ki, hey, let's see what you are doing inside the for loop. So on the inside the for loop you are calculating the number of factors. Okay, and why you are calculating number of factors? You are saying ki, hey, number of factors I am calculating because I have to check a condition. If count is equal to 2, then a number is a prime number, else number is a prime, else that number is not a prime number. So you are saying ki, hey, let's focus on the factor part. So you observed a pattern here, that is, if I know one factor, I can easily calculate the next factor. On that pattern you make a table here, and in this table you again observe a pattern ki after this point, when a is greater than b, you are getting repeated factor, and you have to count unique factor only, and you are getting unique factor at this point. So this observation you have made, this observation you have to tell your computer also. So you are saying ki, hey, a is less than equal to b, I is less than equal to n by I into I is less than equal to n, I is less than equal to square root of n. So for loop you have to run from 1 till square root of n to calculate all the unique factor, right everyone? Yes or no? Till this point is clear? So you are saying ki, hey, let's try to optimize our code. This is my code here. That is, here you are saying I is less than equal to square root of n here. Okay, let's try to write again this part, this one. Okay, and here you are saying this one, right? And you are saying ki the value of num, that is n, is 10 to the power 9, and here you are saying I is less than equal to square root of n. Okay, square root of num, and here you are saying ki, hey, if num modulo I is equal to 0, that means I got one factor. That means what I have to do, I have to write count is equal to count plus 2. Okay, what I am doing, I am saying ki, hey, the moment I got one factor, then I know I will get another factor. So there is no need to add one. Please add 2. Please add 2, because at this point I am getting two unique factor. Everyone is clear till this point why I have written count is equal to count plus 2? Yes or no, guys? Please write in the chat. Everyone, it is clear? This point is clear? You are saying ki, hey, I have to go till square root of num, and you are saying ki, hey, if I know one factor, if I know that one is a factor of n, then I can easily calculate the next factor also. So here I am doing the same thing. If I is a factor of num, then I know I have to add 2, because at this point I am getting two unique factor, right everyone? Yes. So you are saying ki, hey, I have done some optimization on the basis of the observation. Okay, if you are new to the prime number, then you have to think in this direction. Okay, you have to see the like where you are getting the problem. Okay, and in order to solve the problem, you have to reverse you have to do reverse engineering, right? You have to go back, okay, and see the problem, like where you are getting the problem, right? So what is a function square root. Okay, so here like I'm not able to write a square. Okay, this is not a function. Here I'm calculating the square root. Okay, so you can see uh, in the Java how to use like inbuilt function or how to calculate square root. Okay, you can write a simple program. Okay, here everyone is clear. So here on the like for your understanding, I have written square root and num. Okay, this is a dummy code. Okay, not the original code. I'm not writing the code line by line. My focus is on the understanding part. Okay, how you should think of the problem statement, and when you are getting the logic, how to optimize your logic, right, Leon? Okay. So Abhay is saying here, sir, use break after count is equal to count plus 2, more optimization. Okay, yeah, Abhay, you can do like you can do further optimization here. That is the moment your count is greater than 2, break. Okay, but this will not affect much. This will not affect your time complexity for large analysis. Okay, for the larger value of n, when you are saying ki, hey, at this part, right, this part here, you are saying ki, let's suppose the value of n is 10 to the power 9. Okay, 10 to the power 9. So if you are writing this part, that is if count is equal to 2, here break, right, you are writing this part. If count is equal to 2, I will break, because I like count is greater than 2, right, Vivek? I will break here because I know this number is not a prime number, right? So I will move out of the for loop, right? Right, Abhay? So basically, if the value of 10 to the if the value of n is 10 to the power 9, then what will happen? Okay, or let's suppose you are getting a prime number like this, that is 10037, like this. Okay, this one 377. Okay, so here you have to start from 1 till square root of n. In the worst possibility, we are observing our code, we are optimizing our code. Okay, we are thinking for the worst case. Okay, if the value like if the number is a prime number and that number is a very large number, okay, then this condition will not become true, right, Abhay? So okay, Abhay is saying one point here. He's saying, hey, there is no need to write another condition right here, break. Okay, break. So Abhay, tell me, if I will take the value of num is equal to 24, if I will take the value of num is equal to 24, then what will happen? Here, you are saying I is equal to 1. 1 is a factor of 24. Count plus is equal to 2. Okay. After that, you are break. You are doing break. Okay. So the moment you are the program will reach at this line, what will happen? I will move out of the for loop, and here the first condition is true. So since 24 is not a prime number and you are printing prime number, so this logic is wrong here. So this logic is wrong here. Okay, Abhay. So let's try to optimize. Let's try to observe now. Okay, take from I is equal to 2. Okay, Abhay, again, if I will take from I is equal to 2, what will happen? Okay, please write in the chat. Abhay is saying why you are saying I is equal to 1. Why you are not saying I is equal to 2? Okay, please write in the chat, guys. Please write in the chat. The first test case where we fail is what? If the user has to check whether 1 is a prime number or not. Then here we are not writing any condition for that one. Okay, we are thinking for a long perspective, right, in order to optimize our code. Let's see, you will see the observation, you will see the analysis when I'm doing here. Okay, so you are saying, hey, again, this is my optimized code. That is, this time I know ki I have to start from 1 and I have to go till square root of n in order to check whether the number is a prime number or not, right, everyone? So again, you have the same system that is having that is doing 10 to the power 8 iteration in 1 second, right? 10 to the power 8 iteration in 1 second here. So you are saying ki, hey, one iteration is equal to 1 divided by 10 to the power 8 second. Okay. So you are saying ki, hey, if I have to check whether n is equal to 10 to the power 9, is a prime number or not. Then how many iterations my for loop will take? This time my for loop will take square root of n number of iterations. That is 10 10 to the power 10 to the power what, guys? 10 to the power 9 divided by 2. Right, everyone? 10 to the power 9 divided by 2. That means it will do approximately, let's suppose, 10 to the power 5 iterations. Okay? 10 to the power 5 iterations. So my program is now doing 10 to the power 5 iterations, right? So one iteration is equal to 1 divided by 10 to the power 8 second. So 10 to the power 5 iteration will be equal to 10 to the power 5 divided by 10 to the power 8 second. Right, everyone? So this time, how much time your computer is taking? It is taking 0.001 second to check whether the number is a prime number or not. Okay, everyone? So previously, when you are using n number of iterations, when your for loop is going from 1 till n, then you are saying ki, hey, my system is taking 10 seconds to check whether 10 to the power 9 is a prime number or not. And now the same system is taking 0.001 second. Right, everyone? And now let's take the value of n is equal to 10 to the power 18. Okay, 10 to the power 18 here. Again, same concept. 10 iteration in 1 second, 1 iteration in 1 divided by 10 raised to the power 8 second. So 10 to the power 18 iteration means you are saying ki, hey, I have to check whether 10 to the power 18 is a prime number or not. So my program will take how much iteration? 10 to the power 18 ka square root. Right, everyone? 10 to the power 18 ka square root, like this. Okay, and you are saying 10 to the power 18 divided by 2, right? 10 to the power 18 divided by 2. That means you are saying 10 to the power 9 iteration. Okay, this time my square root wala function is doing 10 to the power 9 iteration to check whether 10 to the power 18 is a prime number or not, right? So here you are saying what? 10 to the power 9 divided by 10 to the power 8 second. Right, everyone? This. So this time you are saying, in order to check 10 to the power 18 is a prime number or not, I have to take, my system will take 10 seconds. Okay. So you can observe. Previously, when you have written the brute force solution, then for 10 to the power 18, to check whether 10 to the power 18 is the prime number or not, my system is taking 317 years. After doing some observation, after doing some optimization, my code is taking how much time? It is taking 10 seconds for the same number, that is 10 to the power 18. Okay, so this is the power of observation, this is the power of optimizing your code, this is the power of analyzing. Everyone is clear till this point? Okay, so sir, you took condition as wrong. You are saying it is a prime if it is divisible. Prime number or not divisible by anything except one and itself. Okay, Abhay. So here, if you will see what we are doing at this point, right? Yeah. I am saying the same thing, exactly two unique factor, and that factor are what? One and itself. Okay. And here you can see I have written a condition. If the number of factors are two, that means the number is a prime number. Else that number is not a prime number. Right? Right, Abhay? So the condition is correct, right here? Any doubt you have, Abhay? Please write in the chat. Honey is saying, sir, can you share the resource code and notes with us? Okay, I will paste the note in the, like, the link of the note in the chat. Okay, Leon is saying, I haven't gone to university, I couldn't have known all these after 20 years of in simple school. Okay, so when you are solving a question, you have to first analyze the definition part. Okay, you have to be clear what you want to calculate. Okay, so first what I have done, my problem statement is prime number. I know the definition. Okay. Now I have to tell the same definition to the computer. Okay. So here I have written a simple code, and here I observe the time complexity. Time complexity is too large. I have to optimize the time complexity. So what I have to do, I have to go back from where I have to from where I have start. I have to go back and I have to see like at which point my time complexity is increasing. On that basis, I have to observe the pattern, and on that basis, I have to optimize my code. Okay, so this is the main basic funda of solving your problem statement. Any problem statement you are getting, you have to use the same concept. Okay, first you have to write the brute force solution. Don't try to think of the optimized one. Okay, first try to use the brute force solution, then you have to calculate the time complexity, and after calculating the time complexity, okay, and that time complexity you have to calculate in the worst case. Okay, like if you are working for the Amazon, okay, then the client is coming to you and the client is saying ki, hey, you have to make a software that should solve problem of 10 to the power 8 customer. Okay, my client will not worry for 100 customer. Okay, so Abhay or and many of you are saying ki, hey, if I am doing some small optimization, then it will reduce the time complexity. No, it will reduce the time complexity, but it will not affect the analysis part. Okay, and when I am doing analysis on the basis of large input data set, when I am doing analysis on the basis of large input data set, okay, that analysis is called asymptotic analysis. Okay, asymptotic analysis here. Okay, asymptotic analysis here. And inside this asymptotic analysis, you have the big O notation. Okay, you have the big O notation, and big O notation means big O notation here. Okay, this one. And yeah, in order to understand the big O notation, you have to understand the time complexity. What is time complexity? How to calculate time complexity? Why time complexity is dependent on the for loop. Okay, so this is about our today's session, guys. This is about the observation and analysis part. So Abhay is saying a doubt here: I is equal to 2, I is less than square root of I plus plus if num modulo I break, if count is equal palindrome. Okay, if num modulo I is equal to 0, count is equal to 2, break. So Abhay, if you are writing this code here, okay, Abhay is saying this code, okay, he has a confusion here and he is saying ki, hey, why you are not writing this condition here? That is, you should write the moment the num modulo I is equal to 0, you should write like this: count is equal to 0, count is equal to 2, and break. So Abhay, tell me, tell me if the value of n is if the value of n is 24. Okay, if the value of n is 24, at that time what will happen here? You are saying the value of I is equal to 1. 1 is less than square root of num. Okay, 1 is less than square root of 24. The square root of 24 is what? It is equal to 4, right? It is approximately equal to 4. You are saying ki, hey, 1 is less than equal to 4. 1 is divisible by a num. That means 1 is a factor of 24. So you are saying count is equal to 2. And after that, you are moving out. So the moment you will move out, what will happen? Inside count, you are having 2. Okay. And you are saying count is equal to 2. My number is a prime number. But 24 is not a prime number here. Okay, Ajay? Abhay? 24 is not a prime number here. If you will take 2 also, then also you will get the same result. Okay, 2 is what? 2 is a factor of 24, right, Abhay? 24 divided by 2, you are saying yes, 2 is a factor of 24. That is, count is equal to 2. After that break statement, you will move out of the for loop and you are again executing the if condition. That is, count is equal to 2, prime number. Okay, first and the most important part is what? You have to understand the definition. I have to calculate all the factors, and all the factors are equal to 2. That is, I am getting 2 unique factor. That means that number is a prime number. Okay, Abhay? Yeah, tech is correct here. He's saying ki, yes, Abhay, you are saying if more than 2 factor also, then it is a prime number. But it is not a correct definition here, right? We have discussed about the definition part. Okay, everyone? Any other doubt apart from this you have, please write in the chat. Okay? The question is clear, the problem statement is clear, the analysis part is clear, guys. Yes or no? Okay. So we are running out of the time. Please write in the chat if you have any doubt. Sir, run my code. It will work. Okay, please, Abhay, please run your code. Please run your code. You will get the answer. Okay. Okay, great. So this is all for today's session, guys. Okay. Thank you for joining our essential bootcamp. Hope I am able to clear most of the doubt. Okay. There are still many things I have to tell you, but there is a time constraint here. So I have to say bye bye. Okay. But if you want to learn about the problem solving, if you want to learn about the DSA, if you want to learn about the time complexity and the optimization part, if you want to learn which data structure I should use at which point, you should enroll in our course, that is this course. Okay. Yeah, this course you have great opportunity. This course is starting from 12th November. We have one-to-one mentorship including 15 project, amazing 15 project that will give you the in-depth knowledge about the front end, back end, data science and the problem solving session, right? So you will get the clear and crystal clear understanding of each topic. And apart from that, if you have any doubt, you can ask the doubt in the live session. You have one-to-one mentorship, okay, available. And apart from that, again, if you have some doubt left, then again you can schedule the doubt session and there we will cover your doubt. Okay, here we are having only one-way communication, so I'm trying my best to cover each and everything, guys. Okay, tech, we will give the question after the session. Okay, so apart from that, you will get the mentorship support, you will get the job support, and we are providing you the 100% job guarantee. Okay, we are giving you 100% job guarantee. हमारा aim ही यही है कि we should make 50,000 employable developer, right? We should provide in depth knowledge. Okay, अगर आपके पास in depth knowledge है, if you are having the in depth knowledge, then you are able to succeed in each and every company. Okay, and अगर आपके पास like ऊपर ऊपर की knowledge है, right, then it will become difficult. You will struggle a lot when you will be either like किस्मत से अगर आप प्लेस हो गए, then also you will struggle. Okay, so अगर आप कहीं पर भी हैं, कुछ भी कर रहे हैं, then try to take a part. Okay, आप रैट रेस की तरफ मत भागना कोई भी. ओके, ट्राई टू टेक अ स्ट्रक्चर्ड वे, ट्राई टू लर्न आवर लैंग्वेज, ट्राई टू गो इन डेप्थ ऑन दैट लैंग्वेज. ओके, जिससे अगर आपसे कोई कुछ भी पूछे, देन यू आर देयर टू आंसर ईच एंड एवरीथिंग, राइट एवरीवन? सो कैन वी राइट काउंट प्लस प्लस? या Hasin, we can write count plus plus. Okay, okay, yeah. So apart from that, this is all for today's session, guys. Hope I am able to clear it out. And apart from that, yeah, what you can do here, you are saying कि, hey, in order to mark the attendance, you have to go to the one link, and from here sign in. Okay, sign in, and from here you are saying कि, hey, mark attendance. Okay, from here mark the attendance, give 10 if you are lacking the session, yes. And after that, if you have nothing, if you have something to improve, write in the select that dialog box and submit your attendance, right? So this is all for today's session. Hope I am able to clear all your doubt. Thank you. Enjoy your day and learn all. Okay. Work hard. Okay. Thank you.